All right, so y'all did parent functions in Algebra 2 and in pre-calc.
Yes.
Huh?
You're recording this?
I sometimes do. It just depends. This we'll give it a try. We don't know how it's going to turn out. This is different than last year, so sometimes I try to like redo it when it's different, so that I don't have to like throw random videos. But this will be glorious. I might just quit. So. Yes. No.
Yes.
I did not.
Very helpful for learning.
Isn't it? Don't worry, I can cut all of this out later too. It's good. All right, so parent functions. You may have learned quite a few of those in Algebra 2 and pre-calc. You don't remember them, I understand that, that's fine. Jack's a little but these are the ones we're going to worry about, okay? We have our linear parent function, our quadratic parent function, cubic, square root, absolute value, and rational. So if you want to write those down, you're welcome to write names. We've got linear, quadratic.
What's the name of
F
F?
is the function. It's the same thing as Y.
No, letter like in parentheses.
Oh, letter F.
Yeah.
That's the rational.
Rational.
In fact, we call that one rational odd, because there is a rational even.
Yeah, that's okay.
It's like the volcano one.
Yeah.
Okay, square root. So these are the ones we're going to worry about and be responsible for. At some point, we will do exponential and logarithmic stuff, but that's going to be on its own because we don't need to add to that right now. Okay, we're good with these. Okay? So we just need to know a few basics about things, like how to graph a line, how to graph a quadratic, that kind of stuff. This is where domain and range comes back into play too. So for example, example 1, if you are asked to graph this, what is that?
It's a linear.
Linear. So you would draw yourself a little graph. How do you graph a line?
So you start at 0, 0.
Yeah, not on this one. This one has a y-intercept of what? 3. Okay, so we graph it at 3. We then have a slope of 2. So I go up 2 over 1 or down to left 1. There's my line. Okay. That gives us some of the information we're looking for, such as we now know the y-intercept, right? What is the y-intercept?
3.
3. Do I necessarily know what the x-intercept is? It's something in there, right? Do we remember how to find an x-intercept?
You have to like do something with the y. Like,
Yes. Plug in 0 for y.
Yeah.
Okay? So if I plug in 0 for y, I can use that then to solve for x. So that means I would subtract 3 and divide by 2. So my x-intercept is negative 3 over 2. Now, do we all remember domain and range?
Domain. It's x's and y's.
Yep, there you go. So your domain, you have, okay, so you can write it as negative infinity to infinity. You can also write it how? Did you do all real?
All real numbers.
Either or. Okay.
It's a bad pencil.
Okay.
It's like.
Okay.
That's embarrassing.
All right. Go grab, there's that, or there's some in the drawer over there. What about range? No, give it to me. No, give it to me. Range is the same. All right. Range is also negative infinity to infinity, all real numbers. Do we have a preference? I don't care. No? Okay, fine. All right, so that's specifically normal linear. Yay, easy, yes?
Yes.
Second, what kind of graph is x equals 3? Bless me. Undefined slope, which is what kind of line though? Vertical. Good. So if I'm asked to do the sketch of a vertical line, it's just at 3. Now what does that mean about its domain? Can I say negative infinity to infinity? It's just 3 to 3, which we literally just say 3. What do we call that? That's a quadratic. Yes? Okay, so easiest way to graph a quadratic is to find its x-intercepts and just know whether it opens up or down. Okay? So how do we find x-intercepts on a quadratic?
You factor.
Yes, you factor. So we have x and x.
X
What else do we have there? Factors of 3. 1 and 3. And if I want it to add up to 2 in the middle, it has to be what? Wait. Positive 3, negative 1. Therefore, I have x-intercepts where?
At 1 and negative 3.
1 and negative 3. So if I'm sketching, I currently know I have an x-intercept at negative 3. I have an x-intercept at 1. Do we know whether this quadratic is a normal U or an upside down U?
It's positive.
What part of it being positive? Yep, the A out front of that is positive. Therefore, it opens up. We don't. Not on this one. What do I know about the domain on this one? Negative infinity to infinity. Good. Now, in the next section, we're just talking about domain. If you have to sketch it to know that, that's fine. But the point is more to know the parent function, and therefore, what is the domain based off of the parent function? So, like, for example, this one, A. What would the parent function of that be?
Cubic.
It's a cubic, right? Because it's got an x cubed in it. So that's like the S shape.
Yeah.
Every S shape goes all the way to the left, all the way to the right. Yes? Therefore, what's my domain? Negative infinity to infinity.
Oh, yeah, because cubic.
Yeah. Like, you're not supposed to have to sketch these. E is a linear. What about every line? Negative infinity to infinity. I'm just going to start writing all real numbers because I'm tired of that. B, what kind of graph's B?
Rational.
It looks like the rational, but for it to be rational, where does the x have to be? On the bottom. This could be written like this.
It's linear.
Still linear. Tricky.
It's really weird.
It is. All right, so we're going to go through some of the ones that we don't have a problem. Well, those are the ones that we don't have a problem with. The other ones we do. Okay. So the other ones, 3 of those are rational, right?
Yeah.
3 of them have x's on the bottom. Okay, so how do I know the domain of a rational function if I don't want to graph it? Do you remember what kind of values you can't have in a rational function?
I feel like,
Irrational numbers.
The bottom,
I know, that's absolute value.
Oh, it's the bigger on bottom.
no, that's the horizontal asymptotes, but the trick to the rationals is the bottom can't equal 0. Okay? So if the bottom can't equal 0, everyone look at C. What value does not work for x then? 0. So instead of writing all real numbers or negative infinity to infinity, we write negative infinity to 0. But remember the parentheses says it doesn't actually equal 0, right? And then I say it goes 0 to infinity. Or the other way we wrote that, and I don't know which way y'all learned all last year, is all real numbers, x does not equal 0. Do either of those look familiar to us?
the top one.
The top one? Either or is fine. I don't care. The top one skips over 0 because the parentheses means it never actually equals 0. The bottom one just leaves out 0. Either way. So use that same thought process on D. What x value can I not have in D? Negative 5. So same way to write my domain. Negative infinity to negative 5. Negative 5 to infinity. Or all real numbers, x does not equal negative 5.
I like that.
Okay, I don't care which one. I really use that one when it comes to letter F. How do I know what gives me 0 on the bottom in F? What do I have to do? Factor. So that has to factor into x minus 2, x plus 1 before you can tell me I can't use what or what?
Negative 1 and 2.
Okay, so then this is where I start using that all real numbers x does not equal because I get tired of saying negative infinity to negative 1, negative 1 to 2, 2 to infinity. Like that gets to be a pain. So these ones I start writing all real numbers, x does not equal negative 1 or 2. Last one on this page, and then we have a few things on the next, and we're done. On this one, square roots. Yes. What does the square root one look like? It starts and goes to the right. So what we need to know is where it starts, right? So to tell where a square root function starts, you set the inside equal to 0. So if I solve that, what value do I get? 1 over 2. So what that tells me is that my square root function starts at 1 over 2 and goes out to the right. So if it starts there, I use bracket with 1/2. And if it keeps going to the right, it goes out to where? Mm-hmm. Is this all okay? Finally, we're just going to do some adding and subtracting of functions. And we're done. All right. All of this is just plugging in numbers.
Were you doing all of these?
There was a lightning strike 12 miles away.
Not 10 miles away.
Yes, but this will take me like 5 minutes
Because
because they go quick. What does G of 2 mean?
Means plug into whatever X is.
Plug in 2 for all your x's. All right, so I would like for you to do that one and B. Take a minute. All right, question. If G of 2 means plug in 2 for your x's, what does this mean? Plug in Z for your x's, which in this case means literally do nothing but put Z's in places of x's. Now, if it was D, what am I putting in place of my x's? Okay, so there's a little bit to be done here. Because what do I have to do on the first term?
you have to
Actually, like square it. So it becomes this. Now, we're all going to have to follow along on C. Are we ready to follow along on C, given that we don't have C, these ones? I have 2 C's. Look at that. All right. So given what we have here so far, we plugged in Z for X. We plugged in R squared for X. What do you think this last one means? Plug in that in place of my X's. All right, so what is that going to look like? Let's take a look. 3, take out my X, minus take out my X, plus 5. So that would be like my basic setup. And in place of both of those X's, what am I supposed to put?
X plus H.
X plus H. Now, we're not just going to let it sit here. We're going to simplify. What do you think I can simplify? X plus H squared, I can do what? Foil it. Okay? Distribute, foil, whatever you want to call it. So you can foil X plus H and X plus H. I can distribute the negative to this one. And I can just combine like terms. So let's see what that would look like. I am not going to distribute the 3 until after I foil. If I foil that, what's X times X? X squared. What do I put for X times H? X, H. And the same thing for the middle one, right? And then H times H is? H squared. Now, do I have any like terms I can combine there? This one and this one add together and give me what? All right. I'm going to just erase there so that I can show that and distribute in the next step. Okay? So that's 2xh. So then last step here would be to distribute what? 3. And combine like terms if you can. So I have 3x squared plus 6xh plus 3h squared minus x minus h plus 5. Are there any like terms there? No. One's an x squared, one's an x, one's an h squared, one's an h. Nothing you can do, but you did plug it in and work it out. That's all we're doing right now. Okay? All of example 6 is just learning the notation of sometimes you have both an x and a y. So if I give you a of 1 comma 1, what do you think you're supposed to do with that?
Alright. Plug in a 1 for X and 1 for Y.
Exactly. Like, don't make those hard. Okay? So that is your X, that is your Y. A of 1 comma 1 would look like 1 plus 1 is 2. So now you guys do A of 2 comma 3. And if you get that, go ahead and find B and C. We're just about done. Woo. We are. But it's just plugging in. Yes? All right, last ones here.
Don't do that.
Okay, first things, A and B. Absolute value makes everything what? Last ones. Absolute value makes everything what? Positive. Therefore, the absolute value of 3 is 3. Absolute value of negative 2 is 2. Factorials can be typed into your calculator.
What is a factorial?
The exclamation point.
5 plus 4 plus 3.
Officially, it's times, but yes.
Yeah, it's times.
That means this.
Wait, so like the constant or something?
Okay? It just means that it multiplies every number after it down to 0.